This video is about Linux environment variables, which is the content that's in Chapter 6 of the Blum and Bresnahan book. And we'll start by talking a little bit about what they are, the different types, learn where they live and what they mean. And their use will become very important, particularly as we start to do scripting a little bit later. So what are they? Well, environment variables are variables that the system maintains, that is to say, bits of information that it carries with in order to have a context for whatever commands you might be executing. So within the shell, we have certain variables or little bits of data that are being maintained that know certain things, like who is the user who's currently logged in, and where is their home directory, and things like that. Okay, so there are two different types. There are global variables, and then there are local variables. The difference between the two is essentially this: the global variables are available within the shell and also within any subshell of that shell. So those global variables are basically passed down from the parent shell to a child shell. The local variables are not. Local variables only exist in the shell instance that they have been declared in. So let's take a look at the global environment variables that we have. There are two commands you can use for that. There's first of all the env for environment command, and the second one, which gives the same information. Let me just, before looking at this content, I'll just run the second one, which is print env. So print and then env for environment. Print environment is the way you should read that. The command is print env, and when we run that, we get the exact same content as the other one. It doesn't look different at all. So let me just scroll up to the top here, and let's see what kind of information is here. And most of this is not going to be that useful to you most of the time. I just want to give you kind of a feel for it. Let's see. There we go. Okay, so here's where the command was issued, and then here we see the response, which is these are all the global environment variables. And you'll notice that they all have this format. There's a variable on the left, and don't ask me what an xdg underscore vtnr is. I have no idea what that variable even means. One could look it up if one were interested. But then there's an equal sign, and then there's something on the right-hand side, which is what that variable is set equal to. So these are name and value, or key value pairs, if you like. So a few things. You'll recognize this one right away, right? Shell equals /bin/bash. So that is the definition of a shell for this particular shell instance that's running. Here's the user, which is Perry, as you might reasonably expect. What's this? ls underscore colors, blah, 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 a bunch of color stuff. Who cares? Move on to some more interesting ones. Let's see what else might be interesting here for now. Let's see. Yeah, here's the home directory, home/Perry, for the user that's currently logged in. And scrolling down to the bottom, anything else interesting here? Yeah, nothing particularly. Log name equals Perry, just like the user's Perry, etc. Language is English US, etc. So anyway, that's the kind of information that by default is passed in as a global variable. Of course, there's one more that I did want to point out. I don't know how I missed it, so I'm going to scroll up a little bit. Which is path. Where is it? It's in here somewhere. Here it is. I'm going to show you how to look at just a single one of these variables in a second. But here's the path. Now, if you've done any work on Windows, any development work or anything like that, you may have had to adjust your path within Windows to be able to access certain tools at some point in time. It's the same thing under Linux. There's something called a path. What is this? This is the list of directories that will be searched when you type in, for example, the name of a command. So if you want to execute some command, it will search in these places that are indicated here. And if it's not able to find it there, then it'll tell you it can't find the command. Okay, so /bin is one of those. Notice they're separated by colons. You see that? Each one is separated by a colon in between. And that's just a way of indicating the end of one item and the beginning of another. Here's another /home/Perry/Ben, and then /home/Perry /.local/Ben. Here's /user/local/sben, etc., etc. So each of these is a separate directory. And so if you type a command, then Linux is going to look in all of these places to try to find that command in the order that they're given here. And if it finds one, then it will run it. And if it doesn't find one, it'll say that command isn't found. So that is if you don't qualify it. If I say, for example, /bin/bash, that's what I was after. If I do that, I've fully qualified it with a path. I've said, here's the path I want you to use. It's from the root, the subdirectory bin, and then run the command bash. Okay, and you know what that does from our discussion last week. So I exit. But if I just type bash, how does it know to go there? Well, /bin is actually in the path, and so it knows that it is there. To show just a single environment variable, you would use the same command, that is the printenv, and this doesn't work with just the shorter version, the env or environment command. So use printenv for this, and then give the environment variable or that you're interested in seeing. So in this case, printenv path, and I see just the path. I could do the same thing and say, what's home? There's the home directory as it's been defined for this user. Now, one of the things that's interesting about these environment variables is that we'll be able to use them ultimately in scripts and things. So for example, I can have a script that would have many of the commands that I could type at the command line interface here. I could type them in one at a time, but we might have a command that we want to repeat 1,000 times. Let's say, for example, there's 1,000 files and we want to go in and search each one and put together a list of occurrences of a certain word within those 1,000 files. An easy way, and maybe if it's there, we replace it with something else or whatever. If we wanted to automate something like that, one way to do it could be to make a script that would look at each of the files one at a time, and then do that, and then move on to the next file. And we would be able to put together some structures to do that. Well, in such a case, we might need access to the environment variables and to be able to make use of them. So the way that we make use of these environment variables in other programs, whether scripts or other commands, is we put a $sign before the name of it, and the $sign tells bash that we're interested in the environment variable of that name. So for example, using the echo command, I could type echo $home, and I get the same thing as printenv, right? But what we're doing here is actually sending the environment variable as a parameter to the echo command. The environment variable home is defined as /home/Perry, so I could make use of that for any other command. I could say, for example, this, and I get a listing of the contents of the directory indicated by the environment variable home. Since these environment variables that we see here are globals, they'll be available in a subshell as well. So I can type bash to create a subshell, and you see here that we do indeed have the subshell right here with this process ID that I'm highlighting here. And within that, of course, I can execute the same command, and of course that gets passed along. Okay, this will not be the case when we look at local environment variables. So in addition to the global variables, we also have local variables, and I can see a list of all the globals and locals together using the set command. So if I type the set command, I'm going to get a lot of output. So I'm going to send it to the less command using a pipe. We will talk about that just a little bit later in the course, so bear with me. But I'm just doing this so that I can kind of show you what's in there, because otherwise we'll just be scrolling up through a lot of output. So this gives it to us one page at a time. You remember the less command. So here we see the globals that we saw before, and you've got stuff like this and language and et cetera, et cetera. They're kind of in alphabetical order here, and then here's the path, etc. So we see some of the same stuff there, and then we'll also see a bunch of other stuff. So as I keep going down here, you're going to see just a ton of stuff here. Some of this stuff, these look like functions. That's because they are, and we'll talk about those a little bit later too as we get into some scripting. But in any case, there's a bunch of stuff here. I'm just scrolling down through it. Okay, lots of locals. So the things that are kind of defined as locals here are kind of script code. Here, I'm going to quit and get out of that. But we can also define our own. So let's see what the variable Perry means right now, and the answer is nothing. There's nothing stored there. So I can set that variable to something, and I'll just say Perry equals, how about, we'll say hello. And so now if I echo the variable Perry, look, it's now defined as hello. So what use is that? Well, maybe we'll do something else with it. We'll say Perry equals, and I'm going to put this in quotes because this is, if you have multiple words or special characters, you put it within quotes, and that will make it less likely to have an error, because you can't do spaces and that sort of thing in one value. So let's try this, /home/Perry/ documents. Okay, so now Perry is that. So I can echo Perry again. Now it's that. I could also less Perry like so, and I get a listing of whatever's in the documents directory. Again, where does this become valuable? Well, when we're making scripts and things, this will be very valuable because we're able to set something and use it again later as we're executing a script or passing information, perhaps even from one script to another script, or saving information after the execution of a script. So that will be very, very good. Now, you will notice that the locals, and see, I guess I can, why don't we just execute that command before so you can see that that one's actually in there. As I go down here, let's find the one called Perry, right? Let's see, there it is, right there. I need these start with an underscore. Those are going to be after, so this one would be before. So there it is, Perry equals /home/Perry/documents. So now it's defined there within set. So you'll notice that the global environment variables generally use all caps, and the local environment variables all use lower space characters. This is a convention. That is to say, it's not required, but that's what you generally want to do so that it's clear whether something is a local or a global. Now, as I mentioned before, the local environment variables do not get passed to child processes. Globals do. And so if we wanted to communicate some value to a child process or have it available for the child process, it has to be a global. So how do we make a global? And the answer is, we'll take something that has been defined as a local, and then we'll kind of promote it to make it global. And then when we launch a child process, like a child shell, it will be available in that child shell as well. So let's just see this in action. We know that we have the variable Perry defined, right? Again, we can just verify that with echo. There it is, it's defined as something. So if I were to now launch a subshell, right? So that's just a subshell, 29525 is the process ID. If I were now to echo Perry here, there's nothing defined there, right? So I exit, go back to the original shell, and of course it's there. So how do I get that information if I want that available to the subshell? And the answer is we have to promote it to be a global environment variable. So the way we do that is with the export command. So we'll say export Perry like so. Okay, and now that has become a global. Of course, it's lowercase, which kind of breaks the convention, but that's all right. So we'll go into bash, and we can say then echo $Perry there, and there it is, ls-l Perry, and there it is. There's the listing. Okay, so that's the way we promote something and make it global for this one session. I type exit to go back to the parent, and of course this variable Perry is still declared. But if I exit the shell, okay, and that closes my terminal session because that was the base or root shell there, then that variable is now gone. So I start my shell again and echo Perry, and of course there's nothing there. It only lived as long as the shell where it had been initially created. Now then, if we set it to something here, like so, okay, and you can see that it's defined here, and now I'll export that one, and let's make a subshell, and we'll echo Perry, and you see that it's howdy. Now let me change it. I'll just say Perry equals like so, and just to verify, you see it's changed it there. So it's changed in the subshell now. If I exit that subshell though and look at the parent shell, you'll see that it's not changed. So this is another thing to note. Whenever we have a subshell and we've got a global, we change the value of the global environment variable in the subshell. It does not affect that value universally. It does not affect it in the parent. If, of course, I were to change it right now in the parent and then start a subshell, the subshell would get the new version of it. So if you've done any computer programming before, this is similar to a pass by value. That is to say, globals are passed by value to the child subshell. A copy of the global is made for the subshell, and if the subshell makes any changes, it's just changing the copy rather than the original. To remove an environment variable, we use the unset command from the command line. So unset, in this case, Perry, and we can echo Perry. Like so, we see that it's no longer set. Now, really good tip on page 143, and I like this. It's a good way to remember this. When do you use the $sign and when do you not use the $sign? Well, here's the rule with environment variables. If you're doing anything to the variable, that is, you're changing its value, you're setting it or unsetting it or making it equal to something or whatever, then you don't use the $sign. Okay, so if you're changing its value, if you're doing something to it, you don't use the $sign. If, on the other hand, you are doing something with the variable, then you use the $sign. That is to say, you're just making use of its value. So it's kind of like if you're writing to it in some way, you don't use. If you're reading it, then you do use, or if you're using it as a parameter to a command, I guess would be a better way to say it, then you do use it. And as the tip on page 143 says, the exception to this rule is using printenv to display a variable's value. There you're using it as a parameter, but the print environment command is not expecting to see the $sign, so it's just an exception. So kind of confusing. And sorry about that, but if it doesn't work one way, you could just randomly try the other. But try to learn the tip on page 143 and learn the rule. So there are various variables that are set by default in the shell when the shell is launched, and some of these are from the original Bourne shell. That's named after a person, and no, it's not Jason Bourne. That would be kind of cool, but it's B-O-U-R-N-E. The Bourne shell, and so bash, of course, as I indicated before, is called the Bourne again shell. So that's not B-O-R-N, it's B-O-U-R-N-E. So kind of some Linux developer humor there. But anyway, bash is a derivative or a a descendant of the original born shell. So some of the shell variables that are there by default are from the original born shell, and some are from the bash shell. And there are a couple of tables on page 144 and following that indicate some of those. And you've seen some of them already. So from the original born shell, you know that you've got, for example, the home directory right there. That's one of the crucial ones. I also, of course, mentioned path before, and that's essential. So this one that's really crucial, the path, sometimes it'll become important to be able to modify the path variable so that a program or a script or something that we want to execute is available generally from the command line. And the way that that is done, well, of course, you can first see what the path is, as I've shown you several times. So you want to be able to do this. Echo the path, you can see what the path is. And again, this is a colon separated list, so the colons don't actually mean anything except they separate one from the other. And so /home/Perry/bin is one directory, /home/Perry/ .local /bin is another directory, etc. /bin right here is another one, etc. Okay, so these are all the ones that are currently there in the path. So how would we change that path to incorporate something else, and why would we want to? The book goes through an example in which there's a script that has been produced, and we modify the path in order to run the script, but of course we haven't made any scripts yet, so we can't really do that. So we're going to kind of put together a scenario that we can do now without having a script to run, so we don't have to jump ahead and do that. So let's do this. We know where we are, right? We're in the home directory. So let's make a directory. Let's call it new deer, for instance. Okay, and let's go into the new directory that we've made. And why don't we make a link to something? How about we'll make a symbolic link to /bin/bash, and why don't we call it mybash? Okay, so now then, you'll see that that's there, symbolic link. I'll say cd ... Okay, so now I have this directory called new deer, and within it is something called mybash. That could be anything. All we did was make a symbolic link to bash, okay? But that could be a script of my own that I want to run at some point in the future. So if I just type from the command line here, mybash, obviously the command is not found. So why is that? Because it's not in my path. Now I could very easily do something like this. I could say new deer and my bash like so, and it doesn't look like anything happened, but you see when we type PS, my bash is now running. I can exit, and now it is no longer running. Okay, so that actually worked just fine, but I had to qualify it from where I was. Remember, the dot here means current directory / and then new deer within that, and then / and then my bash is what I wanted to run. But what if I want to just be able to type my bash from the command line here? Because as I showed you before, command not found, right? Well, I want it to automatically find that in my special directory where I've put it. So the way that we would do this is redefine path, and you have to be kind of careful here because we could mess up our path to everything else for this shell session, couldn't we? But here's how I'll do it. Path equals, so see I'm changing it, and so I don't use the $sign. Now what do I want though? I want to read that value, okay? So now I'm just using it, so I'll say $path, and then what do I want to do? Let's add that directory onto the end. Okay, so I'll add that directory, and I'm going to go ahead and make it fully qualified from the root, so /home/Perry/ new deer. Okay, so that's getting added to the path now, and I can verify that that worked by looking at this, make sure it looks right. Take a look. Now we have /home/Perry/ new deer at the end, see, with the colon in between. That's why I added the colon right there. So having done that now, since that directory is now in the path, it should be able to find that because it's going to look at all of the directories in the path to find my bash. And so it did. And again, we'll verify that it's there. I can exit from it, and then of course the my bash is gone. Okay, so that's how we can modify the path. Just path equals $path colon and then add the path that you want to tack on to the end. Alternatively, you could put the new path at the beginning and then a colon and then add $path at the end of that. Now then, once again, if I echo the path, you'll see that that's there. If I type bash and echo the path, you'll see that since path was a global, it's been passed to the subshell as well. And that is a subshell, exit, and we're back to the original. There are three kinds of shells in Linux systems: login shells, interactive shells, and non-interactive shells. Starting at the bottom, the non-interactive shells are shells that you don't interact with. That is, you don't provide input to them and they don't provide output that you can see. Those are used by other processes when they need to launch a shell to accomplish something and it's done in the background. The login shell is the kind of shell that you see when you log in to a Linux system, whether local or remotely. And then the interactive shell is the kind that we've been playing with most of all in this course. It's interactive, meaning you're providing commands and it's providing you feedback in the form of characters that are printed within the console or shell. So the type of shell then also determines where the files live that set up the environment for that shell. So you've got environment variables and also some functions or code that are going to be run whenever a shell is launched, and which of those things happen, where those things live, depend upon the type of shell. We're talking about a login shell. The place that it's going to look is in the /etc/profile. There should be a file there, and we can take a look at that, /profile, and here it is. Now this looks like code, doesn't it? If this, else, etc. This looks like code, and it actually is, and you'll come to understand more of this than you think you will, even in this present semester. Okay, so that's coming. There are a couple of places where other files are referenced. So there's one called bash.bashrc /etc/bashrc, and that one is included here. It's actually executed here on this line if it exists, and if some other things are happening. That is to say, if we're running a bash shell, basically. And then also down here, there's a directory that's referenced. It's /etc/profile.d. That's a directory, not a file. And in the case that that directory exists, then for each of the things that are in there that have a .sh extension on the end, then basically it's going to execute those files and whatever is in them. So you don't need to understand all of this at this point. I'm just kind of pointing you where things are, /etc/profile. In the case that we're talking about an interactive shell, it's a little bit different because now we have the possibility that, we're logged in and we have a particular user, and the user may have kind of a customized environment. You have the ability to customize that environment in a variety of ways. We've talked about being able to change things like the path. You can even change the way that this prompt right here looks to have any information that you want, and can really customize it to any extent you would desire to make your work more efficient or to make it more pleasing to you in whatever way. And those things are done using the files that are going to modify the environment for an interactive shell. So what are those? Well, first of all, when you launch bash will read the /etc/profile file that we've already seen, and then of course that'll incorporate the files that also references. So these things in this file that we've already looked at will modify the environment for bash to begin with. However, this is not the place you would want to make changes to customize the system to your own desires, generally speaking, because most of the time on Linux systems, these are multi-user systems, We don't want to change things for all of the shells that are ever created on that computer by anyone. Usually we want to just change the things that have to do with shells that are created when we're working interactively with the system, any individual user. So after reading etc. profile, it's going to look for the first of some files that start with a dot that are in the home directory. And that is the user's home directory. So for me, that's /home/Perry. For you, it's something else. But it'll look for a .bash profile, that's bash_profile file, a .bash_login, and then finally a .profile, which is not bash specific, it's not shell specific. That works for a multitude of shells. And the first one of those that it finds, it will go ahead and read. And that one could possibly reference other files. So let's take a look at those. We're here in my home directory, as we'll see here, and so we can let's just look at everything here, and we'll see what files kind of look like that. You see 3 of them right here already. We've got a .bash history, but that isn't one of the 3 I listed. We're looking for bash profile, bash login, or just .profile. So then there's bash logout, there's bash rc. Haven't really mentioned that one yet, right? And let's continue down. We're really looking for all the dot files, the ones that are going to be hidden files. Remember, that's what dot means. And here we see it, .profile right here. So that's the one that's going to be driving this thing. And so let's take a look at the file called profile. We'll say cat.profile, and let's take a look at this. Executed by the command interpreter for login shells. Okay. It's not read by bash if .bash profile or .bash login exists. Remember, I told you it would look at those in order. If .bash profile is there, that's the one it reads. Otherwise, it looks for .bash login. If it doesn't find that, then it looks for .profile. So on this particular system, that is to say Linux Mint, in this current version at least, those 2 files don't exist, and so it's the .profile that gets read. And then take a look at this. You can almost read this stuff, right? Look at this. This is an if statement. So how do I read this? If it is the case that the bash version environment variable exists, then that means we're running bash. Okay, and so therefore include the .bash rc. So here it is. It's looking for something called within the home directory. That's an environment variable, right? /.bash rc. Okay, and then it executes whatever is in there. Okay, and then it does some path work down here. Remember, the path is this variable $path, right? And so now path is being set equal to, we're adding a couple of things. So whatever the home directory is /bin, and whatever the home directory is /local/bin, those are being added now, appended to the front of the path. Okay, right here. And so that's the .profile file. Probably you don't want to make any changes to this one. Okay, but let's take a look at the bash rc. This will be the one that's bash specific. So let's look at that. Do we have such a file? I think we already saw that we did, but let's just look at that. And there it is. So let's see what that one looks like. This one I think is a little bit longer, so let's just do it this way so we can look at that thing. Okay, and you can almost read this as well. So take a look, because these things are comments. They start with the # here. So this is actually, you're looking at a bash script here, all right? If not running interactively, don't do anything. Okay, so that's fine. So a non-interactive shell won't do any of this. But interactive shells are going to do this other stuff. And see, it's setting up something for history control. That's setting up an environment variable. You see that? It's running some command right here that has something to do with the history file and appending stuff to it. How big is the history file? How many things does it keep? Doing some stuff about window size, etc., etc. And we can page down. And there's just more and more stuff here. As we go, I'll show you some interesting things. Anywhere where you see PS1 being set, all of this stuff, that's where the prompt that you see in the bash shell is actually being set. So there are ways to customize that, and you can knock yourself out playing with that if you want to. Just Google it. You'll find all kinds of interesting things. I'm not going to do it at this point. Then let's see what else we have. Just going down a little bit here. Here's we're also adding some handy aliases. So which ones? Like some of these, ls becomes this. What do you think is happening there? Well, the ls command without the double dash color option is going to just provide monochrome output, but you notice that we get things that are color-coded based on whether it's a directory or a file or whatever. Well, this sets it to do that in the case that we have a color display, which of course we do, etc., etc. So it does that for various commands, so that's kind of handy. These aliases we looked at last week, some more ls aliases that take advantage of the alias command here to make some handy things so that there's a little less typing involved, and maybe you don't even have to remember what all of these are, right? You just remember ll, and that's a little faster. Various other things. You could put your own in here, but they suggest here that if you want to add aliases, maybe you put it in a separate file called .bash aliases. So you would make such a file with an editor. You would add your own alias commands that look just like these up here, but for whatever commands you want, make whatever aliases you want. And this is set up, this is code that says basically if the .bash aliases file exists, then go ahead and read that and execute whatever's in it. So then every time you start a bash shell after that, it would run that and you would have those aliases available to you. Kind of cool, right? Okay, so so that's it. That gets us, I think, to the end of that file. So what can we do with this? Well, I said you could do things like changing the path. You know what the path looks like right now, right? We can echo path. That's one way to see it, right? The other way to see it, you remember this from earlier, print end path like so, and we see the same thing. So that's the path right now. Let's take a look at what we've got in here. I'm gonna have to clean this up at some point, but I made a directory called new dir. So let's go take a look at what's in new dir. As I look at this stuff, there's a symbolic link here called mybash, which refers to /bin/bash, okay, that I created there. So what if I wanted that to be in the path? Earlier we did that manually, right? But that was a different instance of the shell. I've shut it down since then. So if I were to type mybash right here, this is mybash command not found, I'd like to be able to add that. So how do I add that to my path? What we'll do, I'm going to use an editor, and we're going to talk more about editors a couple of chapters away here, but I want to go ahead and touch one of them real quickly, which is the easiest of the command line editors to use, which is called Nano. So we'll make use of the Nano editor, okay, just like this, and let's modify that .bash rc file. So what do we want to do here? Well, one thing that's really important, sometimes you can be a little bit curious about, is this file really getting executed? There's all this if stuff. I don't know which order the files are being read in. So let's just find out. I'm just going to add a line right at the top, and I'm going to say .bash rc. I can put it in quotes so it's clear what's going on. I'm just going to tell it to echo that to the output. So a couple things about, there's various ways to navigate here in Nano, but the nice thing is most things are right there at the bottom. So it tells you what to do. The main thing you want to know just for very basic editing is how to save the file and how to exit, and it's a little strange. You see the little caret symbol right here, and O. The caret means basically your control key, okay? Or command, I guess it would be on a Mac. So Control O is to write out, and then Control X is to exit. So we'll hit Control O, and it says file name to write, .bash rc. You could change it to a different file name, but generally you just hit enter right there. So see how the cursor is blinking right there? It's waiting for input here. Where do you want to write this file to? I want to write it to the same file that it already is, and it tells you that it wrote it. Now let's go ahead and exit, and we exit. And at that point then, whenever we start a new bash shell, we should see some output if that file is actually getting read. I just wanted to verify that it was. So I'm just going to type bash, and I see that it gives me that output saying that it is starting a bash shell, okay, and that it's read the .bash rc. So whenever I start a new bash shell, it will now do that because that's in the .bash rc file. So I just told it to output that so I could see that. So let me just exit, and oh, it looks like I've got an extra shell in there anyway, so let me exit again. I had a couple subshells going, so now we're back to the root one. That's fine. Okay, so now that we know that file is being read, let's go ahead and modify that so we can take care of our path. Okay, so what are we going to do here? Let me go ahead. I'm just using the page down button here to go down. There's so much stuff in here, right? So much stuff. So, but I don't really care about all that stuff. I'm going to go to the very end, and then down here, let me add one of those comments, and I'll say, you know, append my favorite directory to the path. Okay, so how does that look? It'd be just like what you would do from the command line. I'll just say path equals, and I'll say whatever path already is, right? Add a colon, and then let's add whatever my home directory is. You could specify it /home/Perry, right? But I'll just say whatever the home directory is, and then slash, and what was that called? New deer, I think, right? So I'm going to add that to the path, okay? And then I'll Control O, hit enter to save the same file, Control X to exit, and here, let's just do this so that we're clear on what's happening. This should be the old path. Nothing's changed yet because this file hasn't been run because we haven't started a new shell. Okay. But now if I type bash, I've started a new shell now, and so let's echo path there. There you go. So now you see /home/Perry/new deer is now part of the path. Okay, if I exit though, I go back to the path. Obviously it's not changed in that shell because this shell was started. This is my original shell. This was started before that change was made. Okay, but you know, let me just exit. I'll launch a new shell, and we'll see that that is now persistent. So in other words, I could now say my bash, and that just references bash. We've still got this now kind of annoying thing saying that .bashrc is being read, so I probably want to undo that now, right? So that doesn't keep popping up every time. I'll go ahead and delete that content that I added to the beginning of the file. I just did that to make sure that what was happening in reality was what I thought should be happening there. So that's it for this section, and in the next section we'll roll into Chapter 7 and start talking about Linux file permissions.